Assalamualaikum and good morning to Dr. Razib. We are from Group 1. We'll be presenting our group assignment project, which is Analysis and Characterization of Polymeric Materials. Our group consists of 6 members, which are first is Aisha Batusha with metric number 82795. Next is me, Nurul Arina, metric number 85341. Third is Muhammad Rizwan, metric number 84580. Fourth is Zafri Daniel, metric number 82360. Fifth is Nazim, metric number 84814. And lastly is Muhammad Kushairi with metric number 82680. I will start off this presentation with the introduction of polymer. Polymer is a material component or substance that is composed entirely of several linked particles or units that are identical or distinct and have a molecular build-up structure. Polymer can be categorized to two types, which are natural polymer and synthetic polymer. Natural polymers usually from natural resources like plants and materials that are found in nature. Examples of natural polymers are like cellulose, starch, and protein. For synthetic polymers, it is commonly referred to as made polymers that are created intentionally in lab settings. For examples like plastic bags, water bottle, and other substances that consist of polyethylene, polyvinyl chloride, and so on. Moving on to the objective of this study. In this study, we have chosen to analyze and characterize jeans fabric. We aim to characterize the morphology of jeans polymer using SEM, and the second objective is to ascertain the percentage of oxygen, sulfur, nitrogen, hydrogen, and carbon of the jeans polymer using CHNS.
Okay, so we move on to the methodology of CHNS analysis of jeans fabric. So first step, a 2.5 to 3.0 milligram fabric sample was cut. Next, the sample was cleaned to remove contaminants. After that, the sample was dried at 60 to 80 degrees Celsius to remove moisture. And then it was weighed with a microbalance. After that, it was combusted in oxygen using a CHNS analyzer. And then after that, the gases were separated and detected by TCD. The last step, the results were analyzed for composition. Okay, so next we move on to the next methodology, the SEM analysis of jeans fabric. So first, an approximately 1 centimeter square of fabric sample was cut, and then the sample was cleaned to remove loose particles. After that, the sample was dried in a vacuum oven or desiccator. Next, the sample was coated with a conductive carbon tape. After that, the sample was secured on a SEM stub with adhesive, and then the sample was placed in the SEM chamber. So after that, the beam energy around 10 to 20 keV was adjusted, and the images were captured. So lastly, the results were observed and analyzed.
Based on the method that we have explained before, here are the table results for CHNS, which gives us mean weight, nitrogen percentage, mean carbon percentage, as well as hydrogen percentage. To continue the results, here are the images from the SEM that we have obtained using 4 times 40 magnifications times 200 magnifications, as you can see below here, as well as times 1000 and times 3000. As you can see, they are mostly look like a fibrous type of polymer.
Okay, now we move on to some background of jeans. So first, jeans were introduced by Levi Strauss and Jacob Davis in the 19th century, and were durable workwear for miners at that time. So the denim was traditionally made from cotton, which is a natural cellulose polymer. Today, modern jeans blend cotton with spandex, which is used to improve its elasticity, and polyester, which is used to improve its durability. Today, recycled PET fibers now promote sustainability in denim production.
SEM is high resolution image, while EDX will give the analysis of the composition chemical. SEM, EDX have the different functional role, while SEM used to focus the beam to generate the signal, while EDX used to detect the X-ray when the electron beam interacted with the sample. Some EDX have the challenges during the measurement of the silicon and magnesium due to their low atomic atom carbon. CHNS used to analyze the element C, H, N, also S at the same time at the high temperature, and it can be used in the sector bioresearch to analyze the protein sample, but it can reduce the precise of the result accuracy.
The magnification details at 40 times shows that the texture of the fiber arrangement was rough and also visible groove and microcracks present. It was also found debris on the fiber surface. It shows that the material was susceptible to particle adsorption. The magnification details at 200 times was tightly interwoven fiber structure with frayed edges. It was also had not experienced significant mechanical degradation. The magnification details at 1000 revealed that fibrillation had occurred as the fiber strands started to separate from the main body of the fiber. There were also cracks and pits that shows the sign of fiber fatigue. The magnification details at 3000 shows a cylindrical structure of the natural cellulose fiber. It shows that the genes are composed of a cotton. The roughness, microcracks, and frayed edges of the gene structure are caused from the frequent washing and also drying under the sun. Next, there were also microfiber released around 20 micrometer to 500 micrometer due to washing stresses in the washing machine, according to Grillo et al. 2023 and Nisar et al. 2022.
What is carbon analysis? Hard carbon playing an important role in the structural role of cellulose. Cellulose is consists of closest unit linked by B14 glycidic bond. For hydrogen analysis, it contributes to hydroxy group in cellulose, where hydroxy group play a role in moisture absorption and dye interaction. For nitrogen analysis, low nitrogen content suggests minimal nitrogen-based compound, where a possible source include protein-based treatment, synthetic fiber like spandex, and environmental contaminant or finishing additive.
From this study, we can conclude that the plan for the analysis and characterization of jeans fabric was successfully done as both SEM and CHNS analyses were carried out. As a result, our jean sample will confirm to be made up with cotton as the primary material.